Lesson 19.3, Task 1, Quadratic Functions in Intercept Form. Investigate different forms of a quadratic function. When a quadratic function is written in vertex form, you can identify certain key characteristics of the graph of the function. In the following task, you will investigate another form of the quadratic function that reveals other key characteristics of the graph of the function. All right, so the graphs of four quadratic functions are shown, and if you look here, you can see f of 1 is in blue. You can tell that there's a vertex. There's axis of symmetry. It goes through it's the same as the y-axis, and you've got certain points you could find, but you also know that your zeros are where it crosses the x. F of 3 is the green line here. You've got your zeros. You could find your axis of symmetry. Again, it turns up, so you know A is positive. The blue line here is upside down, so A would be negative for that one. The purple line, it's upside down, so that means that A is negative. The red line is turned up, U-shaped graph, so it's a positive A value. And again, you can locate the x-intercepts, which are called zeros, and the axis of symmetry goes through the vertex of each one of those. All right, so it says the functions graphed here are written in vertex form in the table. For each function, determine whether the graph opens up or down and identify the graph's axis of symmetry. Complete the table for each function. In the last column, enter the constant that completes the equation x equals, and which will be the axis of symmetry. All right, A is negative, so that means this one turns down. This one is negative, so this one's going to be down. The 4 is positive, that's your A value, so that means it's going to be up. And then the axis of symmetry. So if it's in vertex form, it's whatever your H is. So it's going to be opposite -7, which is 7. This one's also in vertex form, so opposite -7, which is also 7. And this one's in standard form, so to find the vertex, you have to do the -b over 2a. Well, b, there is no linear term here, so that would just be 0 over anything is 0. So that one also is easy to check. So it's got a quadratic term and a constant term, but there's no linear term. Remember, in standard form, to find the vertex, you do -b over 2a. With no b, that means that's 0. All right, the functions from part A are shown in this table on the left. Match each of them with its equivalent function in standard form. All right, so remember, to go from vertex to standard form, we have to multiply this binomial out, x plus 7 times x plus 7. Or you can use the formula for a binomial squared. So it'd be the first term squared plus 2ab, which is plus both terms, and then plus b squared on the end. Okay, so if we do that, we're going to write it in standard form. So let's look and see if there's anything. Well, these two are very easy to locate because this one doesn't really have a vertex form where it doesn't have a linear term. So that one's going to match there. We know this one's going to have, excuse me, an A of 4. So that means it's going to have to go here. All right, so you can see if these are matching, it makes it a little bit easier. This one has an A of -2, and this one does as well. So that leaves this one to go with this one. So when you're matching the vertex form with the standard form, you know, if you have to rewrite it, you have to go through each of those steps. If you're just matching those, look for key characteristics of each equation and see if it's easy to match. Okay? All right, so the next one says, use what you have learned about factoring quadratic expressions to write each function in the form y equals a times x minus x1 and x minus x2. So basically that's just factored form. Match each function with its equivalent function on the right. All right, so again, what we would have to do is we'd have to multiply the binomial squared and then add the -9 in and then refactor it. Okay, so to do that, you have to go through the steps to just multiply that out. So write this in standard form and then refactor it, basically, is what you're doing. So if you need to practice factoring again, by all means, go ahead and do that. If you factor a negative x squared out here, you're going to be left with a difference of squares. So this one is going to go with this one. And again, the a value is still the same there. It's kind of easy to pick out. So that kind of helps as well. This one has a 4 in this one, so it's probably going to be here. This one has a -2, and so does this one. So even though you have to multiply these out and then refactor them, if it's matching, again, it's going to be a little bit easier. You can use those key characteristics like knowing what a is in order to rewrite those a little quicker or match those quicker. How are the values of x1 and x2 for each function related to the graph of the function? Select the correct word or phrase to complete the sentence. The values of x1 and x2 are the x-intercepts of the function's graph. So that's the x-intercepts up here above on the image that we looked at before. The x-intercepts are exactly what it sounds like, where it crosses the x-axis. So for the green function, it would be here and here. For the blue function, it would be here and here. For the red and purple, they would be at 4 and 10 would be the x-intercepts. And again, sometimes those are referred to as your zeros, because if you plug in 0, you find your solutions as well. All right, so complete the statements concerning the functions shown. The graph will open up or down depending on the value of a. So a tells you whether it goes up or down. The axis of symmetry is x equals h, where h is the average. Remember, the axis of symmetry is going to be in between your other points. So your axis of symmetry kind of cuts the parabola in half to where it's symmetrical. So what steps need to be taken to graph a function written in the form f of x equals a times x minus x1 and x minus x2? So if you want to graph a function in this form, you could graph your two zeros or your x-intercepts, which would come from the factors. So you said each factor equal to 0 and solve. That would be your x-intercepts. And then you would find the average of those and then use that to find your vertex. And you know the vertex is going to be through that, or on the same thing as the axis of symmetry, which is going to be between your zeros or x-intercepts. Let's see how they state this here on their answer. It says plot the x-intercepts, x1 and x2, find the average of the x-intercepts, and use the average to draw the axis of symmetry. Find and plot the vertex. Draw a parabola through the points. All right, so if you have two x-intercepts in the vertex with 3 points, you can draw the parabola. So that is all for task 1. If you have any questions, let me know. Lesson 19.3, task 2. Write quadratic functions in intercept form. The intercept form of a quadratic function is f of x equals a times x minus x1 times x minus x2, where x1 and x2 are the x-intercepts of the graph of the function. You have learned that the x-intercepts of the graph of a function are the zeros of the function. So x1 and x2 are the zeros of the function, and we call this intercept form. This can also be called factored form. So intercepts refer to your x-intercepts. Again, because it's in factored form, you may hear it both ways. When given a quadratic function in standard form, you can use what you've learned about factoring quadratic expressions to rewrite the function in intercept form, again sometimes known as factored form. Consider the 3 quadratic functions shown. You are given the standard form of the function, the intercept form of the function, and the graph of the function. All right, so you can see, like in graph 1, here's graph 1, standard form, and here's intercept form. You can see that -4 and +1, these are your factors. You set the factors equal to 0 and solve. That gives you your x-intercepts or your zeros. In this one here, you can see that it has 1 x-intercept. So if you set this equal to 0, you get -1. So this one's only going to have one solution. And if you look at the third one, this is standard form. And there's no intercept form. This does not cross the x-axis. So this one cannot be factored, and it cannot be written in intercept form either. All right, what do you observe about the relationship between the intercept form of each function and its corresponding graph? Select the correct word or phrase to complete each sentence. This function, f of x, has two linear factors, so it has two x-intercepts. This one has one x-intercept, and h of x has no linear factors or no x-intercepts. All right, use the given information about functions f, g, and h to complete the table. All right, how many x-intercepts are on the graph? So this one has, if these are not equal, that means this one has 2. If these are equal, that means it has 2 factors, but they're going to have the same zeros, so only 1. And this one doesn't cross the x-axis, so there would be 0 x-intercepts or 0 real solutions. All right, for the function g of x equals -4 times x plus 1 quantity squared, why is it incorrect to say that the x-intercept of the graph is 1? Okay, remember it's always opposite h, so this would be -1. So instead of 1, this really should be -1. How can you write the function more appropriate? Select the correct word or phrase to complete the sentence. So you can rewrite the function rule g of x as, so we're going to write this as x minus -1, so that represents h correctly. The function has x-intercept at your x1, and therefore the x is -1. All right, so it's going to be opposite your factor, or opposite whatever's in here, just like opposite h. So it's going to be -1. So anytime you have factored form, remember if you have factored form like x plus 1 equals 0, to find x you have to subtract 1. That's how you get the -1 there. All right, explain why not every quadratic function can be written in intercept form. All right, if it doesn't cross the x-axis, there's going to be no real solutions, and it cannot be factored. So if it has no zeros, you cannot write it in intercept form. All right, that's all for task 2. If you have any questions, let me know.